Good morning, geometry students. Today's learning target is to compare data sets given dot plots, histograms, and box plots. So if we look at problem number 1, we want to compare the distribution between the number of miles ran by Class A and Class B by answering the following questions. Part A, which class has a greater median? And then the second part of that problem, what does that tell you about the data? So if we look at Class A, we can calculate the median by crossing off the dots. So we'll start at the small and the large, and we'll just kind of keep crossing off until we find the median. And in this process, I see that the median for Class A is 3 miles. And then if I do that for Class B, again crossing off the dots, working my way towards the middle, I'll see that the median is 7. So for Class B, the median is 7 miles. So what that tells me is Class B's center is larger than Class A's center or median. As a result, this tells me that Class A did better than As a result, this tells me that Class B did better than Class A in general. Because its median is higher. If we look at the next problem, it says to compare the spread. And we've talked about the word range. So for Class A, the range is 14 minus 2, which is 12. For Class B, the range is 9 take away 4, which is 5. This tells me that Class A has a larger spread than Class B. Or some people use the word more variability. So Class A has more variability in the miles ran. If we look at problem number 2, we want to compare the distribution of the heights of the basketball and softball players by answering the following question. And you can see 2 dot plots. Part A says which team is generally taller and how do you know? So if you look at the 2 dot plots, first thing you might want to do is look at the axes. So the basketball players, their heights range from 62 to 72. In contrast, the height of the softball players range from 58 to 66. And if I were to find, say, the median for the basketball players, again, I'll just cross off the dots and work my way towards the center. And if I do that, I keep crossing off, I say the median height for the basketball players is 68 inches. In contrast, if I were to find the median for the softball players, again by crossing off, working my way towards the middle, I see the median height is 64 inches. So in general, the basketball players have a higher median, therefore in general, they are taller. So the basketball players are taller since they have a higher median. The second part of the problem says which team has greater variability. Again, we'll use the range. So for the basketball players, the range is 72 minus 62, which is 10. For the softball players, the range is 66 take away 59, and that is 7. So the basketball players have more variability. Since 10 is greater than 7, or their range is higher. Now we're going to compare two histograms. So these histograms are the heights of male and female students at Hinsdale South. The graph may not have came out that well, but which has a greater median? So the male data is approximately symmetric, and I would say the center of the graph is right around here. So I would say the median for the males is around 177 centimeters. It's somewhere between 175 and 180. So it's an estimate. And then for the males, for the females, which is below, it looks like the center is somewhere approximately maybe around here. And that looks like 165. So the median for the females is around 165 centimeters. Again, this is simply an estimate. So in general, the males have a higher median, which means in general the males are taller. So which gender has a greater median? The males, because that's the center of the data. Now if we were to look at the variability, that's again, we're going to look at maybe the range. So for the males, the range is approximately, I don't know exactly what the numbers, but the spread of the data goes from 200, so it looks like 155. So that's approximately 45 centimeters. And for the females, again, I don't know the exact numbers, but that looks like the range is approximately 185 take away 145. So their range is approximately 40 centimeters. So comparing these two numbers, the males' variability is larger. Let's turn over the page and look at the next example. For problem number 4, we want to compare the box plots of the battery life of two brands of cell phones. So we have brand A in green and brand B in blue. And just as a quick reminder, this is the minimum. This is quartile 1. This is the median. This is quartile 3. And then this is the max. And as a reminder, each whisker is 25% of the data. Each box is 25% of the data. So part A, what is the median for brand A and median for brand B? So for brand A, the median looks like around 4.25 hours. And for brand B, the median looks like it's 3.75 hours, since it's in between 3.5 and 4. Then which brand would you buy and why? Well, brand A has a lot of variability, and brand B has less variability. And if I want the longest length, if I look at brand A, so for brand A, approximately 75% of the batteries last 3.5 hours or more. In contrast, for brand B, approximately 75% of the batteries last, and that might be like 3.3, 3.4, I'll say 3.3 hours or more. So in general, brand A has more batteries lasting longer, so I would go with brand A if I had a choice. So brand A in general lasts a little longer. Take a look at example number 5. Again, we are given 2 box plots. And these box plot represents the test scores in geometry of first and second hour. And we want to know which class did better. We want to justify using the center and the spread. So for center, I'm going to use the median. So class, or period 2. So period 2's median is 85, while period 1's median is 80. So period 2, in my mind, did a little better overall. Then in terms of spread, so for period 2, we're going to use the word, we could use range or interquartile range. So for period 2, the range is approximately, it looks like maybe 98. I'm estimating this point here to be approximately 98. This point here looks like it's 60, so the range is approximately 98 minus 60, which is 38. If I wanted to, I could use the IQR. So the IQR looks like it's about 9. This looks like about 90. This looks like about 75. So 90 take away 75, which I think is 15. If I do that for period, that was period 1, excuse me. If I do that for period 2, it looks like this is around 95 and 70. So the range is 95 minus 70, which is 25. The IQR, this looks like maybe it's 91, maybe it's 92, that looks like 80. Again, it's an estimate. So the IQR is around 91 take away 80, which is around 11. So using these measurements, we could see that period 1 has a larger spread or variability. So to answer the question in number 5, which class did better on the test? So which class did better on the test? I would say period 2 did better. Since the median is higher, and it has less variability. And let's take a look at the last example, which is a multiple choice question. Which statement is true about the following? I might use process of elimination. So remember, each whisker and box is 25% of the data. So I'm just going to put that in my box and whisker plot here. So part A, half of the test scores in your class are between 85 and 100. So that's the blue graph. And it does look like 75% are there. So this is false. It is 75% because half is 50%. Letter B, 25% of the test scores in your friend's class are above 80. Well, this is false. It is 50%. So if it's at 50%, it'd be true. For part C, the medians are the same. Well, this is false also. The median for your class, the median looks like it's 90, and your friend's median looks like it's 80, so those are not equal. So by process of elimination, it must be D, but let's take a look at letter D. The test scores of your friend's class are more spread out. Well, if you look visually, the red box and whisker is much longer than the blue box and whisker, so D is the correct answer.